Buenos días, soy el maestro Stone y este es su video para two sample Z testing. Now previously we've looked at taking samples from data and comparing to the mean, the mu of the whole population. What we're going to do now is we're going to take samples from two separate groups of data. So we're going to have two population means. To separate these, we'll call this guy mu sub 1, mu sub 2. Really doesn't matter which is which, as long as you are consistent. And we're going to see, based on the samples that we take, can we say that one group is significantly different from the other, greater than or less than, as far as their means go. So this is going to change how our hypothesis testing looks as well. Our null hypothesis could be something like this. I could say that, well, the mean for the first population is equal to the mean of the second population. And my alternative hypothesis could be, meh, you know what, I think that my mean for my first population is going to be greater than the mean for my second population. So this is going to change a little bit of what we've done. First of all, let's start with how our standard error is going to look different. Let's call this guy SE, but we're going to do a little note down here. We'll call this guy x bar 1 minus x bar 2, because we've got two separate groups that we're looking at here. And what this is going to look like is simply, it's a square root of sigma, the standard deviation of my first group of data. Okay, everything that's got a 1 is going to go together. So my first batch, and this is actually going to be squared, and this is divided by the number of things I've sampled from my first group. All the sub 1s go together, plus the square root, or excuse me, the sigma squared of my second group of data, that's a 2, over, make sure that is very clear, that is a sub 2 down there, over n2. The 2's stick together. Again, that's just the data from our second group. Functionally, this is going to work the same as we have used before when we're looking to try and get a z so that we can do our z test. So I'm going to be specific here as well. I'm going to call this guy z sub x1 minus x bar 2. Okay, just to again stress that we're comparing group 1 to group 2. And this guy is going to look, I've got a numerator and a denominator, much as I had when I do one sample, x bar 1 minus x bar 2, that quantity, minus the quantity of your population mean for the first group, minus your population mean for the second group. Very similar to what we saw for doing one sample z testing, but we are incorporating both groups of data into this. And all this is over our standard error for x bar sub 1 minus x bar sub 2, which just refers to that guy that we just got up there. That's it. Once we've got that, we will get a z-score. Use your z-score on the standard distribution table, and we will be looking for the same type of p-value here. Basically, to date, we have been curious if the p-value is less than 0.05. If it is, that is statistically significant. We have said that's the threshold that we have set. You can change it right now. That's all we're really concerned with. If this is true, then where our p-value is less than 0.05, then we reject our null hypothesis, just like we did before with one sample. If p is greater than or equal to 0.05, we do not reject the null hypothesis. All right. So let us take a look at how this might be used. So let us say that I have got 2 college dorms. Okay, we'll call this this building like the Hoover dorm. Okay, I'm just making this up here, and I don't know if this is from any university, but this is the Coolidge dorm. 2 early 20th century presidents. Maybe they've got dorms named after them. I don't know. But many college students love ramen noodles. They are quite cheap. They are easy to make. They are a staple of many college students' diets. They are also extremely high in sodium, so you probably don't want to have them every day, but sometimes college students do. Let us say that we want to compare weekly instant ramen noodle consumption of the students in Hoover dorm with the students in Coolidge dorm. So I'm going to call this my population number 1 here, and these guys will be my population number 2. Now, in order to do the comparison, we need to know a few things. Let's say that our standard deviation for this group, as far as ramen noodle consumption, is 5. And let's say we do a sample of ramen noodle consumption. Let's say we poll 48 students, and their mean ramen noodle consumption is 14 packs of ramen per week. Okay, that's a lot, but you know, could be. I would seriously don't eat that much ramen 1 week. Don't eat that much ramen 1 week. That you need other things in your diet in order to be healthy. Don't just eat ramen. It's a fine food, but everything in moderation. Don't go crazy. So, I forgot my sub 1 over here, sub 1 over there. So I'm just identifying these because these guys are in group 1. I've got 1s all on my data from the left. These guys are all in group 2, so they've all got 2s in the data. Let's say my standard deviation for my second group here is 3. My X bar 2. Let's say these guys have an average of 12 ramen per week. And let's say that the number of people sampled over here is 42. All right. So notice we don't have our population mean. That's what we're going to make our hypothesis about. So let's set a null hypothesis that, you know what, that the students in Hoover dorm, the mean is the same as the mean here in Coolidge dorm. That basically the 2 dorms eat, on average, the students eat about the same amount of ramen. Our alternative hypothesis could be, well, I see that I've got a mean of 14 here. I've got a mean of 12 at Coolidge. Let's say I want to test, are the students in Hoover dorm having just a bit more ramen than the students in Coolidge dorm? All right. So we'll test this out. First thing we can do is we can find the standard error of the difference between the 2 standard deviations, and remember we set this equal to the square root of, go back to the formula here, everything on the left is for our first group, everything on the right is for our second group. So standard deviation squared, this is 5 squared, over n, 1, so that's 48, and then check your sign, plus standard deviation for second group, 3 squared, over, and our sample there is 42. So this is equal to the square root of 25 over 48. I recommend not plugging everything in your calculator right away and hoping it works for the best. And this gives us the square root of like 0.735, which would give us about 0.857. Okay, let me copy that down over here, put it in the center of the screen. So 0.857 is what we set the standard error of the deviation between our two samples to be. So now we've got the last bit to do, which is just to say that my z-score of the difference between these two is going to equal x bar 1 minus x bar 2 minus mu 1 minus mu 2 over that standard error. That's going to get plugged in right down there, which we said was 0.857. So now I can start plugging in. And this is going to equal 14 minus 12 minus, now here's kind of the slightly weird thing. Our null hypothesis is that these two are equal, okay, mu 1 and mu 2. So if mu 1 and mu 2 are equal, then if I have mu 1 minus mu 2, that's going to be 0. So since I'm testing to see if one is greater than the other, just at all, I'm just going to plug in 0 there, because they cancel each other out. Oh, don't let me forget the parentheses there. All right, and again over 0.857. Simplify the top, you're left with 2 over 0.857, which would give us a z-score of 2.33. Now you can go to your z-score table, and that will tell you that the area, the probability from the left is going to be 0.9901, but since we're looking to see if mu 1 is greater than mu 2, we're concerned with going to the right. We're concerned with this area over here. So do 1 minus 0.9901, and then you are left with your p-value, which is 0.0099. So p is 0.0099. P in this case is less than 0.05, so we reject our null hypothesis, which we said was that that the mean consumption of ramen is in both dorms is equal, and we will go in favor of our alternative hypothesis, which is that mu 1, which is the mean of the Hoover dorm, is greater than our Coolidge dorm, which seems to indicate that the students in Hoover are having just a little bit more ramen. Well, maybe not a little bit, but at least more ramen than the students are doing in Coolidge. Review this. Think if you have any questions. and we can discuss. Thank you very much for your time. I hope you have a great day.